Hi everyone, this is the FRQ question 3 from the packet. This originally came from 2015, number 2, if you want to look up the scoring guideline. So here, blah, 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 long run proportion of 0.2 is their intention. They took a sample, they got 0.15%, and their confidence interval was 0.15 plus or minus 0.06. So I changed that to 0.09 to 0.21. Does the confidence interval provide convincing statistical evidence the program is not working as intended? Justify your answer. So intended is 0.2. 0.2 is in my interval, so I think it could be 0.2. So there's not enough evidence to say that it's not working since 0.2 is included in the interval. So it's a possible true proportion, blah, blah, blah. What did they say? No, the confidence interval is 0.09 to 0.21, which includes the value of 0.2. Therefore, it is possible the computer program is generating discounts. The probability of 0.2 and the confidence interval does not provide convincing statistical evidence the program is not working as intended. Same thing I said, but 20 times as many words, or twice as many. One of those. So section 1 is part AI. So this is section 1. Essentially correct if the response states that because the interval contains 0.2, it does not provide convincing statistical evidence the computer program is not working as intended. Partially correct if the response indicates that it is necessary to check whether the value of 0.2 is in the computed interval, but there are errors in the implementation. For example, the response notes that 0.2 is within the interval, but does not draw a conclusion. The response has an arithmetic error in the computation of the endpoints of the interval, but provides a correct conclusion with justification that is consistent on the computed interval. So if you did something wrong and you got different numbers here, and you got an interval that didn't include 0.2, and you answered consistently with that answer, you would still get essentially correct. Okay, I think that's everything. You can read more carefully if you need to. Section 2 is parts AII, so let's look at what they said and what I said. Does the confidence interval provide convincing statistical evidence that the program generates the discount with a probability of 0.2? So they're saying that it's exactly 0.2. And hopefully my voice was in your head from earlier this semester. 0.2, if 0.2 is in the interval, that provides evidence that 0.2 could be correct, but it doesn't provide evidence that 0.2 is definitely the answer. It could be the answer, but it's not definitely the answer. So it doesn't provide evidence that it's exactly 0.2, only that 0.2 is possible. We can't prove an exact value is correct with a confidence interval or hypothesis test. They said, no, the confidence interval includes values from 0.09 to 0.21, so any value in that interval is plausible value for the probability that the computer is using to generate discounts. So similar, but not exactly the same. Essentially correct if the response concludes that there is not convincing statistical evidence. So I said it doesn't prove. And justifies the conclusion by noting that there are values other than 0.2 is in the 0.2 in the interval. I think with my combined answers, I said it's a possible true proportion. So I'm saying that the numbers in the interval are possible true proportions. So I would mark this essentially correct, I think, but I'd maybe add a note. Any number in the interval. So I think I'm okay, but I'm not exactly sure what they would have done. I'll just add that, and then next time I'll be more specific. Section 2, partially correct if the response correctly concludes there's not convincing evidence, but provides incomplete reasoning to justify the conclusion. Examples of incomplete reasoning include stating that 0.2 is a plausible value for the proportion without giving further explanation. Here I have further explanation. Indicating that having 0.2 in the interval does not prove 0.2 is the true proportion and should never be accepted, or stating that not rejecting the null is not proof that 0.2 is the proportion of bills discounted. So providing a generic statistical. I still think I'm okay. You'll have to judge for yourself what you think for me, or more importantly, what you think for yourself based on what this says. So if you did get the wrong interval up here and 0.2 actually was outside, they would still give you a partially correct here if you answered consistent with that. Or if you just said that there's not convincing evidence with no other explanation, that was actually marked incorrect. So section 3 consists of part B and section 4 consists of part C. Okay, that's easy. So with part B, the formula for margin of error is m equals z star times the square root of p times 1 minus p over n. So they're saying originally my margin of error was 0.06. That came from up here. I don't know what z star is. And then my standard error is the square root of p, which they're saying originally it was 0.15 times 1 minus 0.15 over n. My new margin of error also has a p of 0.15, or a p hat actually. It has the same z star, and it has 4 times the sample size. Then I factored out the 1/4 on bottom. So that was actually the square root of 1/4, so that became 1/2. Now without that, all of this is equal to what I had over here. So I subbed in 0.06 and I got 0.03. They wrote out an explanation in words. I wrote it out with formulas, which I think is easier. Section 3, essentially correct if the response gives the correct value of 0.03 as the new margin of error by using the correct formula, or providing a correct explanation that recognizes that quadrupling the sample size divides the margin of error by 2. Okay. Partially correct if the response okay, so if you got something, if you used the formula and you did something so that you weren't getting as exact of answers, like you actually went out and calculated some of these numbers, then you would still get essentially correct if you're, even if your rounding was a little off, as long as you're accurate to 0.030. So if you made a mistake in your arithmancy somewhere, but you got a number less than 0.06, they give you partially correct. If you just said it would divide it by 2, but you didn't actually divide it by 2, that's partially correct. Or if you gave the correct margin of error without correct justification. Incorrect if you got a value for your margin that was greater than or equal to 0.06. If you did not recognize in any way the new margin of error depends on the square root of the sample size. Anything like that. Section 4 is part C. So based on the margin of error in part B, which was 0.03, would you say the program is working? So 0.15 plus or minus 0.03 is 0.12 to 0.18. No, it isn't working because 0.2 is not included in our interval of possible values. I bet that's what they set up here. Yep, pretty much. Essentially correct. The conclusion states there is convincing evidence the computer program is not working. No, it isn't working. Based on the new margin of error, the interval does not contain 0.2. Or if the conclusion states the intended value of 0.2 is greater than the upper boundary of 0.18, or if the conclusion states the margin of error is smaller than the difference between the sample proportion and the intended long-run proportion. So if you messed up on your margin of error, but your answer was consistent with what you got on part B, you would get essentially correct. Oh, no, you would get, oh, okay, never mind. If you incorrectly got the new interval, partially correct if your answer is consistent with that interval. If you did use the 0.3 and an argument is based on whether or not 0.2 is in the interval, but your conclusion is incorrect, that was partial. Or partially correct if you couldn't figure out B, but then you said the margin of error would be smaller, so you didn't give a specific value in B, but you acknowledged that it would be smaller and therefore 0.2 would no longer be in your interval. They also gave you partially correct, which is a good thing. So that shows that you should still try an upcoming part, even if you didn't get the previous part. And even better, if you made up an answer for B, you can get essentially correct on C, versus if you just generally talk about it being smaller, that would only give you partially correct. So it's better to make up a reasonable answer to use in future parts, but definitely still try the parts. Okay, I think that covers everything. Each essential is worth 1 point here. And then you would use holistic grading if you end up on a decimal to decide whether to round up or down. So if I had chosen to do partial here and I had done plus 0.5, then I would have had 3.5 out of 4. But I think I would have then rounded that to 4 because I obviously knew what I was talking about here, even if I didn't specifically say that it could be any number in the interval. I think that this holistically would round up to 4 if I had done that. But if it had been a bigger mistake, a more conceptual mistake, or if, you know, my work had been really messy here, if my communication overall was bad, then it would have taken me down a notch. So that's why you always want to have as clear communication and work as possible.